Lite mer om oss på Ariadne, vilka vi är. Vi är ett ingenjörsföretag som hjälper med att utnyttja det digitala underlaget för att få fram bättre produkter. Vi vill hjälpa er att jobba effektivare, öka konkurrenskraften och öka lönsamheten. Så om vi tittar på bilden ner till höger med våra kompetensområden så utgår vi från den digitala CADen i mitten där. Och har vi all information i 3D-modellen så blir jobbet mycket enklare när man kan utnyttja det i övriga operationer, till exempel som toleransanalys som vi ska titta på idag. Det underlättar väldigt mycket i alla fall, men har man dem på 2D-ritningen så går det absolut att göra en toleransanalys också såklart, men det blir mycket manuellt handpåläggande då. Våra affärsområden. Vi har mjukvara, vi gör upp konsulting och vi håller utbildningar. Vi är PTC-återförsäljare och vi är som Creo och produkterna där runt omkring, och så har vi Segmetrix då, som har verktyg för toleransanalys som vi tittar på idag till exempel, och CATIA, model-based definition och automatisk kvalitetskontroll. Så har vi Anark som är model-based enterprise och intelligent informationshantering. Konsultuppdrag gör vi det mesta, så det är bara att höra av er om det är någonting ni behöver hjälp med. Och utbildning, då har vi utvecklat de här kurserna själva faktiskt, som vi är riktigt stolta över, med grunderna i toleransanalys och formulläge och film för konstruktör och design för 3D-print. Det finns mycket mera kurser på hemsidan, eller så hör ni av er så ska jag berätta mera. Dagens ämne då, vad är toleransanalys? Ja, konstruktören han sitter ju i en perfekt värld, men så ser det riktigt inte ut efter tillverkningen när man får detaljen i handen. Det finns ju alltid en variation efter tillverkningen. Och sen när man monterar alla detaljer ihop så blir det då en kedja av toleranser. Och adderar man ihop alla de där så blir variationerna väldigt stora i slutändan. Och lösa det här så kan man ju då göra en toleransanalys så man får svar på vilka dimensioner som påverkar mer eller mindre, och man kan ju då optimera toleranserna. Varför ska man göra en toleransanalys då? Ja, men konstruktörerna, han måste ju försäkra sig att bitarna går ihop och det han konstruerar och att det fungerar och att det blir en robust konstruktion. Och produktion, de vill ju veta om de kan tillverka den och även hur mycket kassering det blir till exempel. Så det handlar ju om ekonomi till slut, så det måste ju vara lönsamt. Och fördelar med en toleransanalys är att man får svar på alla de här frågorna. Man blir klar med projekten i tid och man vet att de fungerar. För det gäller ju att vara snabbare än sina konkurrenter, snabbare ut på marknaden. För det finns ju länder som har lägre kostnad på arbetskraft till exempel, så vi måste jobba smartare och det är det vi är duktiga på. Det hjälper vi er med. För man vill ju ha nöjda kunder och blir det billigare med ökad kvalitet och minskad support, ja, då får man nöjda kunder. Så har vi den här klassiska kampen som vi kallar det med vilka toleranser som krävs. Det är att konstruktörerna på sin sida, han vill ju ha snäva toleranser, eller ofta sätter han onödigt snäva toleranser för att vara på säkra sidan. Där tajtar vi till. Medan tillverkning, de vill ju ha lösa toleranser för att sänka produktionskostnader och få ihop grejerna till exempel. Ja, för att få den här balansvågen och peka rätt. Det är precis vad en toleransanalys gör, så att man har det svart på vitt och veta hur man ska optimera toleranserna för att få en optimal produkt. Då ska vi se, då lämnar jag över till Felix här som ska göra en demonstration utav EZtol.
Yes, thank you, Patrick, and welcome everyone to this demonstration. My name is Felix. I'm an application engineer at Ariadne Engineering, and I'll show you EZtol. EZtol is available in this form for SolidWorks, Siemens NX, and CATIA. It is also available as a plugin for Creo Parametric and Autodesk Inventor. And I'll give a short technical demonstration, and I'll show you how EZtol compares to a simple Excel stackup. So in this case, I'll load in a 3D model. I'll have a SolidWorks assembly right here. But as I said, you can also open CATIA products and Siemens NX vials. So the model we're using today is right here. Call it the caster wheel, and it's something you might find under hospital beds or shopping carts. And I'll just move right over to the analysis. Just hide a few parts here. And the first thing we're going to do today is analyze how well these two bushings align. We don't want them to be off center too much, because otherwise we can't fit in our axle and wheel properly. So I say I want to investigate here the coaxiality. I place my annotation in the graphics window, and then I'll define my tolerance chain. First, I'll select all the parts involved in the loop. So we start with the bushing on one side. Next part is the axle support, plate, axle support, and bushing. And after that, I'll just simply select the mating interfaces like that. Go around the loop, and just like that, I've defined my stack up. So it's really easy, interface, super intuitive. And since you have the 3D model, it's also very visual. Just click OK, and just like that, I have defined my analysis. So in the graphics window, we see all the nominal dimensions right here. Can move them a little bit closer to have a better picture. And then here on the right-hand side, I can see all my dimensions and tolerances. I just have to give it a name. I'll just call it coaxiality. Put in a requirement. In this case, I want them to be within maybe 0.15 millimeter, and like that, I get my result down here. So in this case, worst case result, you can see my requirements plus minus 0.15, and then I will get as a result plus minus 0.25. So I don't quite reach my requirements. But how do we get the result? Pretty simple. Right here, we can see we have all the parts. And then we also have the tolerances right here in the middle. So for example, here we have the inner diameter of the bushing, which is normally 12 millimeter, and then plus 0.02 minus 0. And then we have a runout tolerance here of 0.1, referring to diameter A, and then we have the outer diameter of the bushing. And you can see all these tolerances, they have this chain link icon right there. And that means I've imported them directly from my 3D model. So if you have tolerances defined within the 3D model, you can reuse that information for your tolerance analysis and greatly speed up the process. And as you saw, it took me less than a minute to define this tolerance loop and have a look at the result. Of course, we don't also just support worst case analysis. You can also have a look at the statistical result. So for example, like this, down here, we have our target quality. In this case, capability of 1.33. So that's the quality we want to reach. This is a very common denominator in the automotive industry. And then we also have the so-called predicted quality. So that's what we can expect from our current tolerances we've assigned to the model. So currently we can expect 1.18. So not quite our target, but already close. So EZtol will give you automatically not only a worst case result, but also a statistical. And you can choose not only capability, but maybe you would like to work with a sigma value, or for example, defects per million units. That's also available. So there are quite a lot of options to choose from, and you can easily switch between them, which makes it very convenient. Additionally, you get this message, which says calculated results are ignoring potentially significant 3D effects. And this is great information you won't get from a simple Excel stackup. So this says that this analysis might not just be a simple one-dimensional stackup, but could have 2D and 3D effects we're currently ignoring. And this is just to help you to maybe think over your model and maybe do some additional calculation to get a more precise result. But let's have a look at the, for example, contributors as well. So here we see all the tolerances currently involved in the stackup. So we have runout tolerance 2 times for the bushings, and we have position tolerances for the axle support, also 2 times. So right now, we are not quite on our target. So what can we do to improve the result? Well, we can, of course, tighten some of the tolerances. So for example, this tolerance right here, currently I've set it to position tolerance of 0.15. Let's see how our result would look like if I put it on a position tolerance of 0.1. So let's change that. Let's take away. Oh, doesn't want to change. Why is that? Well, it's because we still have our chain link right here. So if I imported the tolerance from the 3D model, I have to first break the link and then changes. Just help you to remember that after you finished your analysis, double check where you have changed the tolerances and then save that information maybe in a drawing as well. So I'll go down to 0.1 here. Now I can see we're quite a lot better. So again, target quality was capability of 1.33, and now the predicted quality is 1.5. So now we are well within our limits. Now I know after I'm done, well, here I've changed the tolerance, and I want to kind of put that change in the drawing as well. All right, of course, for your usual model, you not only have one specification you want to analyze, but multiple instead. So let's add another one. So we have our coaxiality up here. For the next one, I'm going to add the axle and the wheel as well. So right now we want to investigate the distance between the wheel and the top plate right here. So you can see, put my dimension right here. And again, I'll just select all the components which involve the tolerance stackup, and then select the mating interfaces. And it's a really easy and fast procedure. All right, and like that, I've defined my tolerance stackup. Click OK. And I can see here on the right-hand side all the tolerances. I want to give it a name. Let's just call it wheel clearance and an objective as well. So now you can see currently I'm measuring from the center axis of the wheel. It's not really what I want. Of course, I want to measure from the top. So I change it. Here we go. So nominally 14 millimeters. And I want to put, well, a lower limit on it. So we always want to be maybe above 13.5. And just like that, again, I have my worst case result down here. What else do I have? Of course, all the tolerances I've imported from my 3D model, but of course, up here you can see there's no chain link icon, so there weren't any tolerances in the 3D model. And that's no problem. We can work without the 3D annotations. You can put tolerances directly into the EZtol application as well. So for example, the wheel has a nominal diameter of 80 millimeters, and let's put in symmetric tolerance of plus minus 0.15. Of course, I could also put in plus minus or limits as well. And then here from the inner diameter to the outer diameter, I want a geometric tolerance. In this case, maybe coaxiality 0.2, and my datum reference is 8. So again, it's a very easy procedure to add tolerances manually to your stack-up analysis. Down here, you can see something called assembly shift, and EZtol automatically calculates the clearance between the axle and the bushing. So currently we have clearance there. That's not something you will get out of a simple Excel stack-up, but EZtol will automatically look at the nominal dimensions and tolerances. And then I can say, do I want to maximize, minimize the clearance? Do I want to center it or put a float there? In this case, I want to minimize it. All right, and again, we have our worst case result down here. Can switch to statistical maybe. You can see again, target quality 1.33, predicted quality 1.19, so we're not quite there yet. Could have a look at the list of contributors. So quite a few tolerances in the chain. And in this case, we have 2 which have very high contribution. So if I want to improve my result, it would be probably good to tighten one of these 2 tolerances. When I'm done with my analysis, what I can do is share this information with my colleagues. For that, I can generate a report within EZtol, take a few snapshots for one of the main assembly, maybe like that. And then, of course, for each stack up like this, and then just click Generate Report. Where do I want to save it? And then I'll automatically create an HTML document, which has the screenshots I took, the main assembly, the 2 stack ups I generated, and then also some information of each individual stack up, the coaxiality, the result there, and the wheel clearance, all the tolerances within the chain, and the result. And this you can, of course, share very easily with your colleagues. All right, what happens when I'm done? Well, I can save this information in a separate file called an EZtol file with an association to the CAD model. So if I want to add another analysis later, then I can just simply open that file. We'll find the associated CAD model and open that as well. And then I can continue right here. If I want to do any design changes within the CAD model, I just go to SolidWorks, change my model, and then I have the option right here to reload the CAD model, and it will automatically update first, of course, the 3D model and also the analysis. So all the nominal dimensions, and if I did changes to the tolerances, they'll automatically be updated. So I don't have any extra work there, and I'm always kind of on the newest release. All right, thank you very much, everyone. This was a short demonstration on EZtol for SolidWorks, Siemens, and CATIA. and I'll hand it back to Patrick right now for some additional information and questioning as well.
Okej, tack så jättemycket Felix. Då tar vi det vidare och tittar lite på den här utbildningen som jag pratade om här i början som hade utvecklat av oss. Och det är ju lite att konstruktörerna som oftast är osäkra när det kommer till toleransanalys. Och för att få den här bättre förståelsen varför man gör toleransanalys och hur man gör den så har vi både teori och praktik. Vi går igenom alla de här metoderna, CPK, vad det är för någonting och räkneexempel, så att den är mycket uppskattad, en endagarskurs, och den går ju självklart att kombinera ihop med ett EZtol också så man får både teori och praktik, eller